In section 7.5, we're going to look at derivatives of reciprocal trigonometric functions. Last section, we learned that the derivative of sine is cos, derivative of cos is negative sine, and the derivative of tangent is secant squared x. So let's develop the reciprocal trigonometric derivative. So we're going to start using some of our trig identities, and we know that y equals cosecant x is really 1 over sine x, which is really sine x to the minus 1. So now when I take the derivative, I'm going to use the chain rule, so it's going to be negative 1 sine x to the minus 2 times the derivative of sine x, which is cos x. Simplifying this, a negative 1 times cos x is negative cos x. And if I move sine x to the negative 2 to the bottom, it becomes positive sine x squared. Now I'm going to break up sine squared x as sine x times sine x. Forward here, so I had negative cos x over sine x times sine x. And this is really the same thing as 1 over sine x times negative cos x over sine x. Okay, and 1 over sine x, according to our trig identities from pre-calc 30, is cosecant x. And cos over sine is cotangent. And the negative sign just goes out front. So there we have derived the derivative of cosecant x. So let's just write the formal definition. If y equals cosecant u, and you want dy dx, well, the derivative of cosecant is negative cosecant u cotangent u times du dx. Similarly, let's do a couple of examples here. First of all, with cosecant. So if we want to find the derivative of cosecant x squared plus 2, again, I take the derivative of the trig part first, which is negative cosecant. Function tags along, cotangent. The function tags along, and I multiply this entire thing by the derivative of x squared plus 2, which is 2x. So now I can multiply the 2x by the leading negative out front to get negative 2x. Secant x squared plus 2 cotangent x squared plus 2, and there would be the final answer. All right, similarly, we could derive the derivative for secant x by writing it as 1 over cos and using the chain rule. I'll let you try that on your own, but basically if y equals secant u, and you wanted the derivative of y with respect to x, the derivative of secant is secant u tangent u times dx. So if I was wanting to do the derivative of secant squared 2x, well, again, the first thing I'm going to do is I'm going to rewrite this as secant 2x all squared. And now I'm going to apply the chain rule, so the 2 comes out front. Secant 2x drops to a power of 2, and then I must times it by the derivative of secant 2x. The derivative of secant is secant 2x tangent 2x. And then I times all of this by the derivative of 2x, which is 2. So simplifying, 2 times 2 is going to be 4. Secant 2x times secant 2x is secant squared 2x tangent 2x, and that would be your final simplified answer. Again, similarly, cotan x, you could rewrite it as cos x over sine x and use the quotient rule. And if you did that, you would find out that the derivative of cotangent x is negative cosecant squared x. So if y equals cotan u, then dy dx is negative cosecant squared u times du dx. So I'm taking the derivative of this guy here. Okay, the derivative of cotan is negative cosecant squared. 3x squared minus 4x tags along. And then I times it by the derivative of 3x squared minus 4x, which is 6x minus 4. You could factor a negative out of that. If I bring a 2 out of that, times it by that negative, I'll have a negative 2 out front. And that binomial will become 3x minus 2. And then it's cosecant squared 3x squared minus 4x. Okay, so again, there's the review of all the derivatives of the reciprocal trig function. So you can pause the video if you need to copy those down if you weren't able to get them down earlier. And let's take a look at the next one here. So this one here, we look at it closely. This is the product rule because I have two functions. So y prime is going to be the first function times the derivative of cosecant, which is negative cosecant 5x cotangent 5x times 5 plus the second function times the derivative of the first, which is going to be an exponential, so it's itself, times the derivative of the exponent. So cleaning this up, I have a 5 and a negative, so I'm going to have negative 5 e to the 3x cosecant 5x cotangent 5x plus 3e to the 3x cosecant 5x. And now I'm going to take out my greatest common factor of e to the 3x and cosecant 5x, which is common to both. And I'll be left with negative 5 cotangent 5x plus 2 is my final answer. Oops. Okay, this one here, we'll try this one. This is a quotient rule. So again, y prime is going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And the derivative of cotan is negative cosecant squared 3x times the derivative of 3x, which is 3. And this is all cotan 3x all squared. So simplifying this, I get 2 cotan 3x. Negative times a negative is going to be plus. This is going to give me a 6x cosecant squared 3x. Oh, cotan squared 3x. And if you wanted to, you could factor a 2 out of the numerator. And that would be your final answer. Okay, the last one is an implicit differentiation. And again, we're asked to find dy dx. I'm taking the derivative of each term with respect to x. So the first term is 3x squared. This would be 2. And if you remember, we have to times by dy dx. The derivative of secant 4y cubed. Well, the derivative of secant is secant 4y cubed tangent 4y cubed times the derivative of 4y cubed, which is 12y squared dy dx. So now you must isolate all the dy dx terms on one side. Okay, so I am going to subtract 2 dy dx to the right-hand side. I'm just going to change the order here by putting the 12y squared out front. And then I have a secant 4y cubed tangent 4y cubed dy dx minus 2 dy dx. And now I'm going to factor a dy dx out of the right-hand side. So this is going to be 12y squared secant 4y cubed. Again, you don't have to use those brackets in that one, but sometimes it's everything nice and neat. And then subtract 2 And then I'm going to divide 3x squared by this expression here. So I'm going to get 3x squared all over 12y squared secant 4y cubed tangent 4y cubed minus 2, and that's going to equal y dx, and that would be your final answer. All right, so that concludes the derivatives of reciprocal trig functions. So there's your assignment. So give that a whirl, and if you have any questions, you can ask in class.